We are in day 8 of this Mule advanced training. So in this video, we are going to discuss about transaction management. We'll discuss both about local transactions and global transactions and how they actually work internally. And also I'll be discussing about a pattern called as Saga pattern. So very good video. You will actually get a lot of questions in certification, and also it will help you a lot for interviews as well. So let us get started.
In this lecture, we are going to understand more about transaction management. Actually, we have already discussed about transaction management when I was discussing about threads. We already saw how to start a transaction using try scope, and also how to commit and how to roll back. But quickly right now, I'll discuss about various transaction management options and also give a demo of it, right? So there are two ways by using which we can manage transactions. One is a local transaction. If a transaction is spanning across a single resource, we call that as local transactions. And if a transaction is spanning across multiple resources, we call it as global transactions, or we call them as XA transactions also. So let me talk about them clearly. Let's assume that you have a flow. Let's assume that you have a HTTP inbound endpoint, HTTP listener, and when our request comes, what you are doing is in this flow, you are using a DB component to insert into a database, one of the table 1, and then you are calling another flow using a flow reference, and then here you are having a logic to insert to same database but a different table 2 on the same database, and then you have some other logic. Now what you want is, if exception occurs anywhere in the flow, you don't want any data to be committed. So if no exception throughout, then you want to commit. If there is any exception, you want to roll back whatever you did here and here. So here I want a transaction spanning across a single database. We can use local transactions. Let me tell you one more example. Let's assume that I have a flow where again I'm having a HTTP inbound endpoint. You have some components, and here you have a component which is writing to a table on database. Let's say this is database 1, and here you are calling another flow using a flow reference which has a lot of components, and there is one component which is writing to another database 2, another logic. Now this component is writing to one database. Let's say it is MySQL database, and this is, let's say, Oracle database. Now I want everything either to be rolled back or committed. So here I want a transaction spanning across two resources. So this is an example of a global transaction. So in global transactions, we use a protocol called as XA. So global transactions are sometimes called as XA transactions. Okay. So in the same example, I'll modify. Let's assume that in the first flow, you are not writing to a database. You are sending a message to a JMS broker queue. Right? In the first flow, you are sending a message to JMS broker queue, and in the second flow, you are writing to a database. Now, if exception occurs, I want the database to roll back and the message which is sent to queue also to be rolled back. So now I want a transaction spanning across a JMS broker and a database. This is also a global transaction, right? Hope now you got a clear idea. Now let's move on. So global transactions are transactions that involved separate transactional resources. Normally, to support global transactions, we use a two-phase commit protocol. So what are the two phases? One is called as prepare phase and another is commit phase. So let us try to understand how this two-phase commit protocol works and what we need to implement a two-phase commit protocol. So let's assume that I have database as one resource for in transaction and a JMS broker queue as a resource, right? So there are two resources which participate in a transaction. So if you want to implement two-phase commit protocol, we need something called as a resource manager, one resource manager component for a database and another resource manager component for the JMS broker queue. And also we need something called as a transaction manager, right? So now our program should ask the transaction manager to start a transaction. Now what the transaction manager will do? Transaction manager will ask this resource manager to start a transaction. So this resource manager is a database specific resource manager. It knows how to talk to database to start a transaction. So it will start a transaction with its database. And then the transaction manager will ask this one also to start a transaction, right? So on two resources, a transaction is started. In our program, we interact with transaction manager only. We never interact with resource manager directly. So if you ask transaction manager to start a transaction, it will ask the resource managers to start. Okay. Then once our work is done, if everything was successful in our code, somehow, if I want to commit, what I have to do, I have to ask the transaction manager to commit. Now the transaction manager will do commit in two phases. How? First, it will ask the resource manager, hey, prepare for commit. Now what this resource manager can do is, whatever data we have written, we have inserted or updated, it will write it to some temporary files. So first phase is prepare phase. So whenever a resource manager is asked to prepare for commit, the resource manager, it will write whatever we have done in transaction to some temporary file, or however it will persist somewhere. Similarly, this transaction manager, whenever it asks the resource manager to prepare for commit, it will also write the data to some temporary file. Okay. So prepare phase is done. So once the two resource managers give success for prepare phase, then the transaction manager will ask each of the resource managers to commit. So the resource manager is asked to commit, it will show commit. And this will also be asked to commit, it will do a commit. Right? So once commit is successful, the temporary files can be deleted. Now let us see two scenarios. A happy scenario where both the commits will be successful. So if both the commits from both resource manager are successful, then no issues. The temporary files where the data is written, the information is written about transactions. This we call it as transaction logs actually, right? So the transaction logs will be deleted. But let us take a second scenario where first commit by resource manager 1 is successful. So it will delete the temp transaction logs. Now before the transaction manager asks this resource manager to commit, let's assume the database crashed. Something has happened. Right. This resource crashed, maybe JMS broker or anything, it has crashed and something has happened. See, these transaction managers and resource manager components are within our application, right? So the resource manager in our application, before it talks to JMS broker and asks to commit, let's assume that it crashed. So what happened? The data in this database is committed, but here the commit was not successful. Now it is the responsibility of the transaction manager and resource managers to make sure that everything will be fine. After some time, if this recovers, so if this JMS broker or the resource is normal, then the resource manager, what it has to do, it knows that it failed to commit earlier, right? It is the responsibility of this resource manager to make sure that it will ping the message broker or the resource regularly. Once this is up, it has to make sure that whatever data is there in transaction logs will be committed to this broker. So it is the responsibility of this transaction manager and resource managers. Finally, we don't need to worry. Once we issue a commit to transaction manager, and if it says, okay, commit is successful to my application, we assume that the data will be consistent, right? So that's how two-phase commit protocol works. Actually, if you want to implement two-phase commit, you need some rules on how the transaction manager will talk to each resource manager and how resource manager will talk to database, right? So there's a protocol called as XA protocol. So according to this XA protocol, in this XA protocol there are two phases, prepare phase and commit phase. So since we use XA protocol to communicate between resource managers and transaction managers, etc., we call these transactions also as XA transactions, right? Hope you now clearly got about XA transactions. So how XA protocol works? The resource managers participating in global transactions use two-phase commit. These resource managers implement something called as XA interface, so they can be managed by transaction manager. Since these resource managers are implementing XA interface, it allows separate protocols and systems to be combined into one global transaction, because see, database will use different protocols and message broker will use different protocols, but our code will be same because our code will communicate to these databases or brokers using XA, single protocol, right? Okay. There are problems with two-phase commit. What are they? It requires remote communication to each participating system. So whenever you are implementing a two-phase commit, it requires communication to remote resources, right? And requires each participating system to support two-phase commit. So first thing, an important thing is the database and JMS, they have drivers in our application, right? Both the drivers which we are using, the JDBC driver or the library which we are using to communicate with the broker, they should both of them support XA protocol, otherwise it is not possible. So suppose if you are having a database which does not support XA protocol, then you cannot use as global transactions, right? Okay. Now, and one important thing is, as long as a transaction is alive, it will lock the participating systems. Of course, you know, like transactions will take locks, right? So these global transactions will lock the participating system for the duration of transaction. So maybe a performance will be a bit affected, right? So there are some problems with two-phase commit protocol, and maybe all resources may not be supporting this two-phase commit protocol. In such cases, what you have to do, how to manage transactions. So in such cases, we cannot achieve consistency immediately. See, in case of database or broker, what we do, either everything will be committed or rolled back. So data is consistent. We are achieving consistency immediately. But if your resources do not support global transactions or two-phase commit protocol, then you have to go with eventual consistency. You have to assume that eventually everything will be consistent. So eventual consistency can be achieved by implementing a design pattern called as Saga. So what is a Saga actually? Saga is nothing but a series of local transactions. Okay, so I'll explain you. So actually, why Saga pattern? Saga pattern is an alternative to XA, where your resources are not XA capable or XA is not desired, right? So features of Saga pattern include it maintains consistency across multiple services without requiring a transaction management system. It uses a sequence of local transactions. So failure of a local transaction executes a series of compensating transactions that will undo the previous successful transactions. And of course, to implement Saga pattern, you need complex programming model. You need to write your own logic to implement Saga pattern. So let us see an example. There are two ways by using which we can implement sagas. One is choreography based and another is orchestration based. So actually let us try to understand the concepts of choreography and orchestration. So orchestration, I guess everybody knows. So to tell orchestration simply, it is nothing but a process which coordinates with multiple resources to get the work done. So actually, whenever we are writing our flow, we say that our flow is doing orchestration. Let's assume that you have a flow which talks to service 1, get the data, talks to service 2, get the data, use some transformations, and talk to service 3, get the data and return back. So here I can say that my flow is having orchestration logic, orchestrating across service 1, service 2 and service 3. So the process of coordinating with multiple services and getting the desired work done, I can simply call it as orchestration. That you know. So where is my orchestration logic? In a flow. I can write orchestration logic in a flow. Okay. So I'll tell you a very simple example to demonstrate about orchestration. A non-technical example firstly. Let's assume that I am driving my car on road. Do you think traffic signals are required while driving my car? Yes, of course. Without traffic signals, we cannot manage the traffic. So can I say that traffic signals are taking a decision whether traffic should move left, right or straight, right? So can I say that traffic signals are orchestrating the traffic? Yes. So they are controlling how traffic moves, right? I can say traffic signals are orchestrating the traffic. Okay, fine. But now let's say I'm not driving my car. I am walking in a crowded area. Like I went to a temple and I'm walking in a crowded area. Do we need traffic signals while walking? For walking people? No, right? So let's assume that I'm walking and somebody came opposite to me. What I do? I may take left and then take a right. I'll take my own decisions. And again somebody is coming. Again I'll take a left and then take a right. Again somebody is coming. I'll take right. So what I do is when walking, I don't need any system to control how the traffic is moving. Everybody has their own mind. They will take their own decisions, take left or right or left or right or whatever direction they want, and they do their own dance. Actually, right? When I'm walking by taking left, right, etc., I'm doing my dance. Or I can say that I'm doing my choreography. Right? So now you understood choreography. In choreography, every person will take their own decision and move forward, right? Okay, now once you understand this non-technically, let us see with an example of how to implement orchestration based Saga and choreography based. So firstly, choreography based. Let's take a simple scenario. I have let me copy this here. Let's take a simple scenario. I have three services: order service, payment service and delivery service. So whenever order service gets an order, it will prepare the order and save its data in database or whatever. And let's say after order is prepared, then it will send a message to orders to the payment service. So payment service will receive this order success message. Once it receives, what it will do, it will take payment and then send payment success to delivery service. Delivery service will receive the payment success and it has to prepare for delivery, right? So suppose if the delivery is a failure, right? Then what should happen? Delivery service should send a message called as delivery failure message, right? Payment service should receive that delivery failure message and then do a compensating action. Earlier it has taken payment, right? Maybe this will revert the payment. So it will do some compensating action to revert the payment. And my order service also should be listening for the same event, delivery failure, and what it should do, it should update the order saying that order has been cancelled due to some reason, right? So in this case, actually what? When the order came, order related data is committed to database. Payment related information is committed to database. But when the delivery failed, what? It took, these two systems took the message and then they did some compensating action to revert or to undo the changes whatever has been done earlier. So this is called as compensating transactions. So actually, are we achieving consistency immediately? No. First data is committed and then later we are doing some compensating action to undo the changes. So we assume that data will be consistent eventually, right? So we achieve eventual consistency. So in this case, there are three systems: order service system, payment service system, and delivery service system, right? So every system is deciding what events to listen for: order success, delivery failure, or delivery success, etc. So every system will take its own decisions on what events to listen for, and whenever such event occurs, it will take a decision what to do next, right? Is it not same like choreography? Everybody will take their own decisions based on some events. Yes. So this is an example of choreography based Saga. Here we have three local transactions, each service having its own local transaction. A series of transactions is called as a Saga, and this series of transactions are happening in choreography based style. Every service is having its own, is taking its own decisions on what events it should listen for, and whenever such event occurs, what to do next, right? This is an example of choreography based transaction. Saga, sorry. So here there is no central component which is controlling the flow. Everybody is taking, every component is taking their own decisions. But now let us see what is orchestration based Saga. So I'll just copy this orchestration based Saga here. Okay. Yeah. Now again here also there are three services. Now what, whenever an order comes, it will come to a separate component called as Saga orchestrator. Maybe in Mule you can think of this as a separate flow, and these all are different flows, right? So whenever order comes, it will come to a Saga orchestrator. Now it will send, this flow will send one message to order service to create an order. If it is success, what to do next is decided by Saga orchestrator. If it is a failure, if the order service gives a failure message, what to do next? Roll back the order. So the Saga orchestrator will have decisions. We'll have to take the decisions. Okay. Let's say order is created successfully. What to do next? Payment. So the Saga orchestrator will ask the payment service to take the payment. If the payment is a failure, what to do next? The orchestrator will decide. Roll back the payment message, right? So if it is success, again, the orchestrator will decide, okay, I have to send a message to delivery service. So like that, this central component is responsible for taking decisions on what to do next. If success from a service, what to do next? If failure from a service, what to do next? So if you are writing a Mule application, maybe in your flow, you have to write your logic to handle all these scenarios. So it looks like very complex, right? You have to call a service, handle exceptions if any, if no exceptions, take some decision, if exceptions, take some decision. It's really complex to implement, right? So basically, if you are implementing Saga, it is really difficult. Actually, you have to write your own logic. Actually, this is an example of orchestration based Saga. Here, this component is orchestrating the control, right? So whether you use orchestration based Saga or choreography based Saga, you have to implement. So this is a pattern, that's all. And Mulesoft, using Mulesoft, of course, you have to write your own logic to implement. There is no ready-made solution for implementing Saga. So for the exam purpose, maybe you just should have knowledge about what is a Saga pattern, right? I'm not going to show you an implementation. You can write your own implementations, your custom logic, right? So that's about orchestration based Saga. And one more thing, when we are writing transactions, right? Forget about Sagas. Now coming to transactions. For every transactions, I told that transactions logs will be created, right? Transaction logs will be returned to this folder under your Mule runtime. By default, this file can contain up to 50,000 records. Or what you can do is you can configure the transaction log size in MBs also in your configuration like this, right? So based on the transaction logs will be written, and these transaction logs will help us in committing or rolling back a transaction. So Mulesoft has a transaction manager called as Bytronix transaction manager, right? And we can use this Bytronix transaction manager to start XA transactions. And one important thing is each Mule runtime can have only one instance of Bytronix transaction manager, which is shared by all applications. So each application cannot have its own transaction manager. You should have only one instance of transaction manager, right? And regarding transaction timeouts, you can configure transaction timeouts either in wrapper.conf if you are having a standalone Mule runtime, or in Cloud Hub, you can actually configure these properties in the runtime manager. Or by default, the transaction timeout is 60 seconds. If you want to set any properties, you have to, this is a property name to set for transaction timeout.
So till now, we understood conceptually about transactions. Let us now see with examples. Okay.
So I have a very simple example. I have a flow already. So this flow is containing a HTTP listener listening at /save. I'm expecting some query parameters, and if you see in this first transform message, I'm expecting query parameters like name, brand name, and original price, and creating this JSON. Then and also I am creating a variable called as bname with the value of query parameter brand name. Then I'm inserting into products product table. Here to which database am I inserting? If you see the connector, I'm inserting into a database with name db1. Then the next insert is for another database. If you see here, sorry, it is same database db1, but to another table in the same database called as copy product. And then I'm simulating an exception in this transform message. If the bname variable is Samsung, I am calling fail function to throw an error. We do not accept Samsung, else returning the payload. And if everything is fine, I am setting the payload as inserted successfully. This is the flow. Now I'm doing two inserts into two different tables. One is product table of DB1 and another to copy product table of same database. So I want a transaction spanning across single database, single resource, right? So I had started local transaction. So see what I did. I wrapped everything inside a try block. Here I said the transaction action is always begin, and I want a transaction type as local transaction because transaction is spanning over a single database, right? So let me go to my database and see DB1 first. Let me select from DB1. Oh, there's already one product. So better I'll truncate this table to show you clearly. And in copy product also, I will truncate. Okay, so now let's see. Select star from copy product. There are no products. And from this product table also, there are no products. Now I will start my application and then try to give a request and see whether transactions will work or not. Okay, deployed. So I'll go to my Postman and give a request. So I'm giving a request to /save and I'm passing name as Siva product, brand name is HP, not Samsung. So send. Now let us see. I got a response, success response inserted successfully. So since the brand name is HP, it will not throw any exception, right? So let us see in my database, both tables, is it inserted? Yes, in product table, if you see, I have one product HP, and in copy product, I have same product. So transaction was successful. Now let me make the transaction fail by giving the brand name as Samsung. Okay, this should result in an exception. Yes, I can see that exception. We do not accept Samsung. Right? Now the transaction, the whole transaction should have been rolled back. Let us check if there is one more row here in copy product. No, there was only the previous row, one product. And again copy this product also same. So the transaction got rolled back. Now in this case, I was having a transaction spanning across a single database. So local transaction was sufficient. Now I'll modify this. I will go to this insert and I'll select DB2. Right now, if you see this connector configuration for DB2, it is pointing to database 2, right? Okay. Then and now I will change this table name as product in DB2. Okay. So the first one is inserting into DB1 product table. Second one is inserting into database 2 same product table. So here I want transaction to span across more than one resource. So I want global transactions, right? So first thing I need to do is in my try, I'd select here start a XA transaction. Okay. Then in this one, in advanced, you can see I have configured the transaction always join. This one also in advanced, if you see, join if possible. If there is transaction, join, otherwise no. So I can make it as always join. So here in try block, I configure the transaction type as XA, and in this one I asked both of them to join, right? So when you are having XA transaction, as you understood in earlier lecture, we need a transaction manager. We need to configure a transaction manager. But let me check, did I configure a global element transaction manager right now? No. So I want you to observe firstly what will happen if I don't configure any transaction manager, but still I configured for XA transactions. Let us check. And in the meantime, before it starts, I'll go to a products table and I'll truncate this products table so that there'll be nothing. And here in DB2 also, I will truncate the table. So in both databases, products table is empty. Okay, so let us check. I think it's still starting up. Okay, deployed successfully, but now let us try to insert by sending HP right now, anything other than Samsung. Oh, I got a message saying cannot start XA transaction. Let me see the error here. Here it's saying object of type Java X.transaction manager with name transaction manager is not available. So this clearly says that we need to define a transaction manager. So let me show you how to configure the transaction manager. I'll go to global elements. I'll click on create. I'll select Bytronics. So Bytronics is a library which actually gives us a transaction manager, and Mule 4 uses Bytronics transaction manager. I just configured it as a global element. Okay, now let me restart it. Okay, it got deployed. So now let me give a request to insert. Should be successfully inserted in both the databases. Let me check if there is any error here. Oh, there is an error here. It is saying operation insert extension of databases uses transactional connection, default DB connection, but the current transaction does not support it. Oh, one more thing I forgot to do, and that's good to do a mistake here so that you'll also understand clearly. So I configured the try scope to use transaction type is XA, but my database connectors also should be configured so that they will start XA transaction. So I'll go to database connector, edit it. In transactions tab here, I have to select use XA transactions. Similarly for DB2 also, I'll go there, transactions, use XA. So this has to be done because the databases should create XA transactions, right? So now if I restart, it should work. So it's getting restarted now. Let's see. Okay, so it got redeployed. Now let me give a request and see. Yeah, now I got inserted successfully. So let me check in both the databases. In DB2 products table, yes, there is one product inserted, and in DB1, yes, there's one product inserted. So everything was fine. Now let me test the exception scenario. I'll give brand name as Samsung so that I'll get exception. Both of the databases should be rolled back. So here you can see the stack trace. We don't accept Samsung. And let me go and check if they got rolled back. Yes, you can see only one product. Here also you can see there is only one product. So everything got rolled back because of exception, right? So now you understood how I was actually configuring global transactions, how I am using transaction manager. But it will be good if my example involves more than one resource, right? So in this case, of course, I am using two databases as two resources. In my next example, I want to show you how I can use JMS and also database. So here I have an example. What I want is, I'm having JMS listener in my flow, which is listening for messages inside a queue called as in queue. And whenever a message comes, I am logging it and setting the variable JMS payload with the value. Then I'm publishing to which queue? Some queue of the same JMS broker, and inserting into database config1. Here it is pointing to db1. Okay. Then in the transform message, I am just simulating an exception. If the variable JMS payload is hello, return HP, else fail. Just throw an exception. Now I want a transaction to be started at the start whenever the listener receives. So what I'm going to do is, if the source of the flow supports transactions, we don't need a try scope. Here I am not using try scope to start a transaction, right? So in the source here, if I go to advanced, there is transaction type. Here I configured always begin XA transaction, right? And remember, there is primary node only. So remember, whenever a transaction is started in the source, same thread will execute the entire flow, right? Yes. So if you are having a cluster, selecting this primary node only here in this case tells that only the primary node of the cluster should actually receive and start a transaction. You can uncheck it if you want any node to receive it. It's up to you, right? So now let it be. Anyway, I'm not having any cluster right now. Here I configured the JMS listener to start a XA transaction, and here in the publish advanced, I configured it to always join, and the DB1 also advanced join if possible, or maybe I can even say always join, whatever. So actually, whenever I'm configuring the JMS connector, I need to make that XA compatible. So here if you see my JMS connector, in the configuration, if you see, there is a checkbox to enable XA. If you want to use XA transactions, you have to select this checkbox, enable XA in the connection factory configurations. I have done that. And also I have already configured Bytronix transaction manager as I discussed earlier. That's all. So let me run this. Here I'm showing you a global transaction spanning across one JMS broker and database. Let it start. Okay, it started. To kick off the flow now, what I have to do, I have to send a message to InQ. So I already have started ActiveMQ here. Then let me just go to 8161. Go to Manage ActiveMQ Broker. Okay, now queues, if you see, there is a queue called as in queue. There are 0 messages. I want to send one test message, and I want to send one message to in queue, and I want the message body to be hello. See, if the payload is hello, I'm setting a variable called as JMS payload, and here my transform message is returning HP if the payload is hello, right? So no exception. So let me send it. There should not be any exception. The message should be consumed, and see now the message is there in some queue, same message hello. Yes, and also it should be in the database. So here I think, in which database is it? DB1, I guess. Yes, DB1. So here in DB1, if I select star from product, you can see Siva brand. Earlier this product one row was already existing. Okay, this is the one which got inserted, right? Both the transactions are committed. Let me simulate an exception right now. Okay, see the queues now. There is one in the sum queue, right? I'm going to send another message with payload as something else other than hello. I'll pass Siva, my name. Now this should result in an exception. Let us see the console. See, just for testing, this exception is raised. It is showing. And now I should observe that there is no data in the database. If I again query the same table, see, only previous rows are there. And in this sum queue also, if I refresh, there was only previous message, there is no new message. So everything got rolled back. So that's how we can actually manage global transactions in Mule. Hope you understood clearly about transaction management.
So what you can do is you can download from my Git repository. You can go to DAY08 and there will be documentation on how to implement these transactions. Whatever I have told you, you'll be able to implement it on your machine. Follow the instructions given in the lab guide in my Git repository for this advanced course. Before you go to next lecture, complete this exercise. I'll see you tomorrow.